This question says water flows through the big pipe on the left and there's no air in the system. So as water enters, it completely displaces the air and the entire volume of the pipe will be occupied with water. And then the question continues, the cross-sectional area of each of the smaller pipes is exactly half that of the big pipe. So by cross-sectional area, we're referring to this cross-sectional area here for the top smaller pipe and here for the bottom pipe. And this means that either one of these cross-sectional areas is equal to half the cross-sectional area of the big pipe, or in other words, the sum of both of these cross-sectional areas is equal to that of the cross-sectional area of the big pipe. Now, the resulting question is, what will be the velocity of the water flowing through the smaller pipes? So how fast will water flow through these pipes? And we have three answer options. Option A is greater than that of the big pipe. Option B is equal to that of the big pipe. Or C, less than that of the big pipe. Now, we're talking about water, which is incompressible. So therefore, we know the mass flow in must be equal to the mass flow out. So this is to say the amount of water entering and leaving the pipes per unit time must be the same. So then if we consider the trajectory of water, first again it enters through the big pipe on the left until it reaches this juncture, at which point it will split into two different paths and travel through both of these pipes. Now again, our guiding principle for this problem is the mass flow in must be equal to the mass flow out. So if these two smaller pipes sum to have the same cross-sectional area as the cross-sectional area of this big pipe, well then, therefore, the flow of water in the smaller pipes will be equal to that of the big pipe. And perhaps the best way to see this is to consider what would happen if we shrunk the cross-sectional area of these smaller pipes. So in this case, again, we still need to satisfy this condition. The water in must be equal to the water out. So if we have a smaller cross-sectional area, well then that means more water has to move more quickly so that we see the same amount out as in. But because there's no change, the flow is equal, and therefore the correct answer is B.